Welcome back. Previously on implementing high availability and disaster recovery in Postgres, we have installed Postgres and set up some configurations. We've configured Postgres with different database, create a new user. Again, if you miss the video, check out the link on the description, or you can also click on the one appearing on the top right corner of your screen. Now, today we are going to implement continuous archiving. By continuous archiving in Postgres, I mean pretty much configuring the WAL file or the WAL file. Continuous archiving Postgres consists of continuously archiving the WAL file, which stands for write ahead log. The WAL file logs all transactional queries to a tiny small file. Usually it is 16 megabytes before writing the change made onto the disk. So if there is one thing you can retain from this video, is that there is no continuous archiving without the WAL file, the write ahead log. So in this video, we will demonstrate how to configure the WAL file so that you can apply a continuous archiving. So it is important to keep in mind that you don't have to log your WAL file on the operating system. You can log it on the external drive so that in case of a operating system crash or hardware failure, you will be able to replay the WAL file in tandem with the physical backup so you can recover your database. Okay, so in this video we will pretty much configure the WAL file logging, and we will therefore implement continuous archiving. Without further ado, we are going to launch our primary server. First, we need to cd onto the directory where the vagrant file is located. Cd documents postgres and make sure we have the vagrant file. So we do have the vagrant file, vagrants up Simbulu. So Simbulu is our primary server, and I'm using vagrant just because I wanted to demonstrate the way more than one operating system will be used in Postgres. I'll pause here and then I'll be right back in a second. Okay, our primary server is running. Now we need to SSH onto our primary server, vagrant SSH Simbulu. Normally in a production ready, you wouldn't use vagrants the way I'm using that to deploy your critical data. You will deploy your Postgres either on cloud or both on cloud and on premise using AWS, Azure, or the Google Cloud platform. Okay. Now we are SSH into our primary server. Bear in mind, in this video, I will exclusively use the primary server because we are using continuous archiving. We are now talking about continuous replication, which requires that we use both the primary and the standby. In this particular video, we will focus exclusively on the primary server so we can turn on the continuous archiving and then backup all the WAL file. Okay. First, we need to make sure that Postgres is running. Sudo service Postgres status. So Postgres is running on the primary server. Now we need to turn on the WAL archiving. As I have mentioned earlier, WAL stands for write ahead log, which means that for every transactional query or transactional logs, Postgres will be in charge of logging the change made on your databases before writing those changes onto the disk. By the disk, I mean the physical disk. Okay, so to do that, we need to go to the Postgres configuration to turn on the archiving of the WAL file. Let's sudo nano. You can use vi. I like nano. It's much simpler. etc postgres 14 main postgres.configuration. Okay, we are in postgres.configuration. We need to look at some of the directives that we will turn on or set with different values so we can, allow the primary server to start logging any change made on the database. And this is different than using the pg dump, which we will cover that in the upcoming video. The pg dump just consists of, dumping your logical database structure with some data and then allow you to recover that. But when we are using the WAL file, we are logging everything that's happening to the database, not one database, but throughout all the cluster of the database. Let's look at the property called, since I'm using Nano, you need to press Ctrl W to search. We look at the property archive mode. The archive mode by default is, off or deactivated. When it comments, it's off. We need to turn that on. Or the archive mode just tell Postgres to allow archiving the WAL file for this server. That's the first directive. The second, we have the archive command, which tell Postgres what's gonna happen. What is the command the Postgres need to use in your operating system to copy, as you can see here, example, test file, and if the file doesn't exist, copy that to the directory. So since we are using Ubuntu Linux, we are going to use this command. We are going to test that the file exists on our PG backup driver. Remember, in the first video on this series, we've instruct vagrants to mount a new driver or a new folder that creates a symlink between that folder to the host operating system. And this is where we're gonna use that folder to continuously or archiving our WAL file. So this folder should exist onto your virtual machine. PG backup driver. The percentage, F stand for the file. Check if the file exists, and copy. The P stand for the driver, which is the current directory. If the file doesn't exist, let me put the comments down so it's maybe. If the file doesn't exist, copy the new file onto the driver backup driver. That's the second directive. The third one we need to use is the WAL level. Ctrl W. WAL level. By default, it's replica, but we need to turn it on. It tells Postgres which type of data the WAL file should contain. Does the WAL file contain a minimal type of data, which means, we don't need more information that should be replicated to the standby server, or replica type. If we set to replica, the WAL file, we almost have the data enough to be replicated. And we have also the logical. So we will set that to replica, WAL level replica. That's another directive. Let's continue saving. To save, I click Ctrl O and then I confirm with enter. The next directive, we look at the archive timeout. The archive timeout directive tells a Postgres when it's time to create a new WAL files. As I mentioned earlier, by default, the WAL files is of 16 megabytes. But when there is change in your different database, one or multiple database, and Postgres notice that there has been change, with commits, Postgres will save the change in your PG, a directory called PG WAL. That's where all the files are. It's called PGWO. When we look at that, I'll show you. So when you activate the archive timeout, you're just telling Postgres when is the next time to create a new WAL file. So in our case, we say 300 seconds. So in the next 200 seconds, a new or what we call checkpoints. A checkpoint in Postgres is simply the hash that Postgres creates to compare the file that you are on your database and the one that has been the change that was made. The same with Git, using hash to compare files. Okay. So we have the archive timeouts, which means in 300 seconds, we will have a new segment, as you say, false log file to create segments switch. A false log file segment to switch after this. Okay, we're going to save that. But one more directive that I wanted to point. Let's look at the fsync. Let's look at the WAL level. Yeah, the fsync. The fsync by default is off. What the fsync does is that the fsync tells Postgres when you are logging the WAR files, don't wait, immediately write the change onto the disk. I know it's kind of like it's a little bit complicated, which means there is a difference between the log files which record the change and the actual data that can be written to the disk. And with fsync, if we need to turn it on, it's really important because let's say you just log a change made to a database A, and right after you log the change, there is a crash to your operating system. So at that time, Postgres won't be able to write the change onto the disk. But if you fsync that, Postgres will automatically not only log the change made, but we also write those change to the file system. Okay, now we can save and Control X to exit. Now, since we've made the change onto Postgres configuration, we need to restart. Sudo service Postgres restart. We restart. Let's check the status. Postgres is running. Now, as soon as we turn on the archiving mode to on, Postgres will start checking what was the last change made on the database, and it will create our first WAL file. Let's go verify our WAL file created. So to check that, sudo, we can cd onto var lib postgres 14 main. Let's cd to main. We can cd to main. We need a sudo web permission, sudo super user. Oh, look at this. Let me show you something. Sudo su, which stands for super user. If we just inverse that, sudo us. Interesting, right? Okay, sudo super user. Okay, now we are cd to this folder as a super user, or cd to main, and this is where we can find our famous folder pg-wal, cd to pg-wal. Yeah, so let's see cd to pg-wal and list that. By default, we have this file, the 001 ending with 11. This file is the first record that WAL has been, saved when we create our database and the configuration. Please do not delete this file in the beginning. If you delete that, you have some problem logging in. So wait until Postgres himself replaces this file by creating a new one. Even if we have configure Postgres to automatically archive our WAL file, which will enable continuous archiving and then continuous replication in the future, still we haven't made any change. So we only have this default file. We need to make a new change on our database so we can start logging file. Let's go Okay, so now let's go do some change in our database. 192, 168, 56 for database person, user, Willie. Okay. Now, if we check to list all the database, we can see we have the database person right on top. Okay, now let's insert into person value defaults. First name, let's say Josue. Last name, Kula. Okay, we will insert something into our person table. Let's select that from person. We got a new record. Now let's verify what's gonna happen in our PG. This is still the cluster defaults or folder where all the WAL files will be written. Let's see what's gonna happen. As you can see, we have different records, which means the archiving mode is turned on. Now Postgres can write or can archive or change made onto our database. Okay. Now we need to verify that. Remember that folder, that PG. Remember the folder. Let me quit here. Remember the folder PG CD PG backup driver. We create a symlink to the host or driver folder. We need to make sure that it's writing here. It should be writing. But as you can see, it cannot write to this folder because if we check the permission for this folder, we will see the folder belong to vagrants. It doesn't belong to Postgres, so cannot write the WAL files onto this path. Okay. If we try to change the permission, let me change permission. I can change the owner to. Let's change the owner of this folder to Postgres. Right? We change the owner. We assign. We say from now on, this folder belong to user Postgres and group Postgres. If we list with permission, we can see that even if we've force vagrants to change the permission, but the folder still belong to vagrants. So we need to go back, do that on the vagrants file and reload the application. So to do that, we need to exit. We exit here. We also need to exit. Now we are on the host operating system. Okay, let's go update the vagrant file. Code vagrant. Now, this is where vagrants is creating the folder PG, the quote unquote PG driver, the external driver, should have said. We need to sign the owner. The owner of this folder will be Postgres. The group will be vagrants. Since vagranties take precedence over Postgres, I just signed the owner to be Postgres and the group to be vagrant, which means Postgres will be in charge of writing and vagrants, since vagrants is a super user. Okay, we save that. Remember, you need to make, and this is just because we are working with vagrants, but when you are working with your cloud or external or drive, let's say you're working with EBS in AWS, you're going to make sure that that EBS you mount to your EC2 belong to Postgres, or give Postgres access to that, and Postgres will be able to write your WAR file onto the EBS. Cool. Let's save that and go reload our primary server. Now we are reloading, we are applying new setting so we can overwrite that setting. Instead of that folder belonging to Vagrant, it's gonna now belong to user Postgres, which is gonna allow Postgres to automatically write file onto the directory. I'll pause here for a second while we are reloading our system, and I'll be right back. Okay, our primary server is running. Let's SSH to our primary server in Bulu. Now, let's verify that the properties of pg cd ls pg ld. Now we can see the folder pg backup belong to Postgres, and Postgres is on group vagrants. Okay. Now let's see into that. As we can see, we now have our continuous archiving, being successfully written, all the logs are being written to the external drive, which is good. So now in case there is a crash on this operating system, we can just use the face backup, the face physical backup, now the logical backup, and replay this WAL file. We can recover the database as it was its previous state. That's all for continuous archiving. Now we are doing continuous archiving, which means every 300 seconds, Postgres will checkpoints, by checkpoints, I mean, Postgres will verify the status of our database and the status of the physical file. The physical file, which is located on CD. Let me show you where the actual data file are located. Postgres, it's located on CD var lib postgres sudo su main. If we go on the base, the physical data are located. We can list that so you can see. As you can see, this is the UTC time we've just created with the fsync on. As we check fsync on, when we write new or write ahead log file, it automatically creates also the actual data that we need. I'll conclude this video here. We've successfully turned on the continuous archiving. In the next video, I will talk about backup, simple backup, the PG dump backup, and then we talk about the continuous replication. Thank you for watching. I'll see you in the next video.